Hey, try to get closer to here or what?
Yeah.
Okay, just keep it.
Yeah, just, hey, me and you, just.
And if you make a mistake and, you forget something, we can stop, get your thoughts and start again. Yeah, and I'll just edit later. Well, I'll just answer your questions. Then you move on to the next one, right?
Yeah.
You want to give me a clue when you're finished?
Well, no, I mean, I'll know, because you'll kind of just be looking at me and you'll pause. I mean, I consult I listen and talk to people for a living. I mean, I'll get a feel for when you're like, wrapping up and your thought process, and I'll just peel on to the next one.
Today we have Bartol, president of Bartol Research, and Outbound MagProbe, revolutionary technological breakthrough in testing electrically operated cells. Oh, that's cool.
Makes a point really
I would wait, and then, like, if you know I'm going to ask you that, just reach down and pick it up.
drop it in.
Yeah, but I mean, I think I keep the glass just so there's not so much junk there in front of you right now. Or yeah, just right off to the side, sure.
So this is voltmeter front up and just for demonstration.
Oh, that's so cool.
Why do that? Just keep that out of the way.
No,
That's
you're
right.
Hi, this is David Kalstrom with Outbound Excellence, and welcome to our Spotlight on Technology series. Today we have Bob Bartol, the founder and CEO of Bartol Research, and also the inventor of the Bartol MagProbe. It's a revolutionary technological breakthrough in testing electrically operated solenoid valves and relays. Welcome, Bob.
What does all that mean?
Yeah. Well, do us what? Introduce us to the MagProbe.
Sure.
6 different valves and 2 diode shafts and David Kalstrom from Outbound Excellence. Welcome to our series Spotlight on Technology. Today we have with us Bob Bartol, the founder and CEO of Bartol Research and the inventor of the Bartol MagProbe. It's a revolutionary technological breakthrough in testing electrically operated solenoid valves and relays.
He's on TV once a few weeks.
It's a non-contact method for testing electrically operated solenoid valves and relays. It's 99% faster than a voltmeter, right?
Yeah.
Isn't that what it is?
Go ahead and test your light. Yeah. How's it look there? Is that okay? Get my full throat clear here. Okay, one more time. Okay, testing 1, 2, 3, 4, 5. Here we go. Test. Amplitude perfect. Okay, go ahead and test the light. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and the date?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
One more time, Dave.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, we'll try it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Okay. Any time limit, or just go for it?
Yeah, just go for it.
All right.
Okay, we have with us Bob Bartol, founder and CEO of Bartol Research and the inventor of the Bartol MagProbe. It's a revolutionary non-contact method. Hey Steve, do me a favor.
What's that?
Erase where it says revolutionary technological breakthrough. You can just take a piece of the paper towel.
Okay. Where is it?
Where it says revolutionary, yeah, just that line. Yeah, and then in there, it's the...
And this one, in testing
no. So, and take that black marker, because I'm wired, is the reason I don't want to unwire myself.
Where's the
It's
marker?
right there behind the paper towel.
This one?
Yeah.
Okay.
So it's the... it's a non-contact, so right in that open space.
Right here?
Yep. Method of, and then just erase in. It's a non-contact method. It's a revolutionary non-contact method of testing electrically operated solenoid valves and relays that's 99% faster than voltmeter.
That's it. That sums it up right there. Yeah, that's good.
Can you grab it out there? Can you take a picture out there?
Oh yeah.
In here?
Yeah. You want a picture? Or you want?
With Jesse and everything. No, picture that I can send to Tim.
Okay. Say hello.
Hello.
Can you guys look at me just for a second? Yeah. Jesse? Oh, come on, Jesse, you do it.
Oh, what do you want to do?
See your teeth.
Oh, okay.
Can you get a pretty good shot from right there?
Yeah, it's a good shot there. That looks good. Get a couple angles. I'm going to do one with the sun on my back. But you guys turn toward me. This way would be good.
You get kind of a wide angle with that?
Got everybody. There.
Yeah, send me a couple of them that, just like two of them that show a complete, that I can send to Tim. Hello, this is David Kalstrom with Outbound Excellence, and welcome to our series Spotlight on Technology. And today we have with us as our guest Bob Bartol. He's the founder and CEO of Bartol Research and the inventor of the Bartol MagProbe. It's a revolutionary new non-contact method of testing electrically operated solenoid valves and relays that's 99% faster than a voltmeter. Welcome, Bob.
Thank you, Dave. It's my pleasure.
Oh, cell phone's off.
Oh yeah, good idea.
Cell phones are off. Yeah, mine's off.
I'll turn mine off too.
So I'll give you the number, Jess, and it's just a week from Monday.
Okay, alright. And then, before we finish today, before we leave, I need all your information, contact information, you know, whatever information you have on you.
So in case you need to ask me questions when you edit.
Well, on the final edit, I will have your name, information, contact, you know,
Phone number,
phone numbers,
website.
everything. And when you talk about these things, can you grab them?
Yes.
So I know what you're talking
Yeah,
about,
I'm
so.
gonna pick them up and
Okay, so when I get the tight shots later, I know which one you're,
exactly.
what you're talking
I'll
about.
I'll just go pick this up, test
Okay.
these, and
Okay.
move on.
You think if we put that little footstool right next to you, and then we put some of those devices on there, I mean, you're not, do you
No.
need them all at
No,
once?
I don't.
or even on just your lap if it's not going to
Oh, yeah.
fall, or I can put it, but I mean, just so it's not so, yeah.
Oh, there we go. And I can pick them up and show them.
Will that glass sit against the back without falling over? No.
I think it will, yeah.
Yeah, I take pane glasses, everything, just really clean. Even spread the other just kind of to the side, because the main thing you want to see is not the battery, but that's what I think it should do. It's just,
So they won't inherit that, but that's a little relay used in elevators. That's the one they have the problems with.
well,
Because
sure
they're
to
so
tell
tiny.
them that.
Yeah, they're so tiny, yeah. They're called ice cube relays.
Oh, okay.
That is a major
Oh, that's
problem.
an ice cube relay.
That's it, they're a major problem in testing elevators. Because in the banks of there'll be like 50 or 100 of them. And you know which ones should be activated, but how they get to testing.
No, I hear you.
And these are plugged in. From the back, there's Jim's.
Left side, you mean, left side camera?
Yeah, right. But from the front, you can go down and test each one. Isolate.
Yes, it is. Ready.
Okay. Stand by, everybody. Okay, I want to open up with a single shot of you, Dave,
Okay.
as you greet whatever you
Yep.
want to say. And then I'll open up to t-shirt.
Yeah.
Every once in a while, look to the camera.
Okay, could you do me a favor, have a little package there with instructions in it? I got a white tip that I should have, just in case we're moving out there. I'm sure we will. Right here, right in front.
Oh.
Little. Yeah, just on the other side. Thanks.
Whoa! Never thought about that.
What was that? Bird.
Bird came flying in. Decided I'm probably not supposed to be in here.
Okay, when we're ready, are you all ready?
We're ready.
We all ready.
Okay, stand by, everybody. We stand by, we got speed, stand by. Okay, test your mic one more time.
Testing 1, 2.
Test your mic.
Testing, 1, 2, 3,
Okay.
4, 5.
Okay, stand by, everybody. And 2, 1.
Hello, this is Dave Kalstrom with Outbound Excellence, and welcome to our Spotlight on Technology series. And today with us we have Bob Bartol, who's the founder and CEO of Bartol Research, and he's also the inventor of the MagProbe, which is a revolutionary new non-contact method of testing electrically operated solenoid valves and relays that's 99% faster than a voltmeter. Welcome, Bob.
Thank you, Dave. My pleasure being here. What the MagProbe is a primarily an efficiency tool, so a technician can move in and isolate a electrical from mechanical problem in about 2 seconds. And which normally it takes a voltmeter like anywhere from as much as 10 to 15 minutes to make the same test as it does in 2 seconds.
Okay, let me ask you this, Bob. Tell us a little bit more from a technical environment, and will the MagProbe operate in humid conditions?
Yes, it will, Dave. In fact, the test we did initially on this was we took 4 units and immersed them in a quart jar of water and let it sit. And after 30 days, only one failed. So that was a test for not only for waterproofing, but also for explosion proofing, since it's completely sealed and it's environmentally secure from all the gases or any extraneous volatile explosion conditions.
How about in extreme cold and hot weather conditions? How does the MagProbe hold up in those type of environments?
Well, Dave, it's been used up in the north slope of Alaska in offshore drilling rigs. But the one up in Alaska was particularly significant because the temperature was all the way down to 80 below zero. Now, the initial test we did on it for temperature, we inserted 4 units in a cold chamber that was 80 below zero for 4 days. Only after 4 days, none failed. Then we went from minus 80 degrees down to plus 160 degrees Fahrenheit. Again, we didn't have a failure. But what the unit is spec'd at, the specification is a minus 40 degrees Fahrenheit, which covers the whole range of temperature.
Okay, let me ask you this. Sometimes parts become magnetized during the manufacturing. At what level of magnetism will the MagProbe detect?
It will detect down to 3 Gauss, and in some cases using the little ring magnet that comes with it, you can adjust it to down to 1 Gauss. And some of the ones we manufacture, we can't sell because they detect the Earth's magnetic field when they do that. However, we don't sell them that sensitive. But it's essentially can detect that low Gauss reading, which is important, 3 Gauss, which will affect the operation of the solenoid valve if it retains that magnetism.
Okay. When we test large solenoids and relays, the magnetic fields may overlap. Can you reduce the sensitivity on the device?
Yes, very easily. Now, originally we had a little white cap here. This is what we use. And in there is a magnetic shield. And since it has a battery in it, we place the shield on the tester to prevent it from turning on when we don't want it on. But this also used, if you want to reduce the sensitivity, slide this over, which shields the tip. And then you won't detect the overlapping field. Say there's a large solenoid here and a large one here. They generate large magnetic fields which may overlap. So you place it with this and hold it up to the one you're testing, and you'll cut out the magnetic field from the adjacent solenoid.
All right. One thing I see as far as the LED, now what happens in bright sunlight when you're operating? How are you able to see the LED in that type of environment?
Well, we did encounter that problem from the customer, and what they did, they said they were wrapping electrician's tape around the tip and looking down this tube that they made. When they use it outdoors in bright sunlight, it's hard to see an LED. So we developed this little tube here, a little plastic tube, that slides over the red cap. And when you do that, you shield out the sunlight, and you can look down the barrel and see it. That's especially valuable on the oil companies and refineries and on natural gas drilling operations too, outside with so many solenoid valves.
All right. Well, when I get it near a magnetized field, I guess the light goes on. How do I actually know that it's working before I start troubleshooting?
We also include this little magnet is in the tube of each one, and what it does is you can either increase the sensitivity with it, or you can do this as self-test. Now, as far as that goes, self-testing, before you use it, you can hold it up to the little magnet, and there it is, it works. The biggest problem that people encounter with test instruments is, does it work or not? When it doesn't light, is it working? Is it malfunctioning or not? Well, this overcomes that by getting a self-test before and after a test. So you're sure, when you test it, you know it works. And that's critical because, it leaves you guessing if it doesn't. But that's a nice test for that.
All right, and what powers the MagProbe?
It's a lithium battery, and the shelf life of the lithium battery, we selected this because typically when, say, an alkaline battery fails, it doesn't fail all of a sudden. It goes down kind of a slope, decreasing in voltage until it's intermittent. But in the case of a lithium battery, when it quits just sharply, and it doesn't operate. So with an alkaline, you may say, well, it might work this minute, and then the next minute it doesn't. Because you're right at that crossover point to failure. But with the lithium, it does. But with the lithium battery, there's a big advantage in that. The shelf life on the lithium, typically these that we use, is 10 years, and after 10 years, you only use 5% of its operating capability after 10 years on the shelf.
All right. Have you had customers encounter problems now with new solenoid valves?
Yes, we have. In fact, we had a customer call and he said, I have a solenoid valve that I'm using, and I have it's turning on when the power's off. And I said, well, he detected a magnetic field with the power off. And I said, well, that can't be because it should be demagnetized in the core. Well, come to find out, I said, well, is it disconnected? I said, off. He said, not only off, it's on the bench. And that's it. And so he said, he tested again. He said, I still detect it. I said, uh-oh. So I looked at that. Well, typically with a magnetic core or magnetic material, when it's demagnetized, they want it to reduce to the smallest amount so you don't detect that it won't affect the valve. And this is called retentivity of the magnetic field. If it's present, they can degauss it, but in the case of a solenoid valve, you can't. So when it turns off, you should not detect any magnetic field in the core. If you do, the core has been contaminated with material that shouldn't be in there, that retains the magnetic field. Now this can cause an intermittent operation because it's right on the edge of the open or closing the valve. And for example, if you're riding it's an aircraft and it's bumpy weather, it can make that valve open and close. And this is critical because if you have fuel control valves, it can cause it to turn off and maybe come on again. But intermittent can cause a flame out of the engine.
Well, Bob, it sounds like you've got a revolutionary breakthrough here that is going to really do a lot for the technology in the market as far as test and solenoid valves. You know what? We got to redo these flies are just driving me crazy, man.
Okay. Yeah. Okay.
You know what though? I mean, the whole point of the starting was to do the demo. I mean, we never demonstrated how it worked. I mean, so I thought we were just normally going to start with that. So I mean, I just figured let's go through it anyway. I got to close this thing, or these flies will drive us crazy. But the whole thing that we want to do, and I say, tell me a little bit about it, was to see the demo of it,
Okay.
so people could see how it works. Yeah, no, those flies will go.
Well, we do the demo and then see the button in.
Well, you know what I mean. I thought since we were started, I mean, let's just, you know, it was good just to go through it. But I mean, the main thing.
Here's what I'm discovering, because I'm only getting one camera today. Do you have the questions in order? Are you asking the questions in order?
Yeah.
Okay. Go ahead and ask the questions with you outside the shot,
Okay.
so I can hear your voice. But I'll have a high shot of you.
Okay.
Then we'll go back, and I'll get all the shots you'll be asking the question. Real quick. Just one question after the next.
Okay.
Do you want to do this separately and dub it in?
And then, well, whatever you want to do the demonstration, and I'll get a tight shot of that while you're doing
Well, I
it.
thought after you ask the questions, well, I could do it while he asks the question, give the demo on.
Yeah.
Dad, let Jesse know how to
Well,
do
no,
it.
I'm just
No,
asking,
yeah,
there's two
well,
ways we can do it.
Well, I don't know the demo, so I don't know what you have to do, but
Well, I just take it like this, but turn it on.
Yeah.
with the
Why don't you run us through the demo real quick? I'd like to see it too and see how it.
because it doesn't have to be in order. I can put it where it all makes sense.
Right, yeah, I know, you can dub it in.
So,
So we could just do one question at a time. And,
yeah, just take your time, and whatever dead air, I'll eliminate the dead air and make it flow real easy.
Oh yeah, those flies, man. They were sitting there. I like this.
I had another clip over there.
Okay, remember your
Yeah, I know,
okay.
one up there. That
What
clip,
do you-
I have that clip there. There's two alligator clips right there. That's it, yeah. Oh, thanks.
Sitting there right as we were in, I got a fly sitting on the end of my nose.
Yeah, so, yes.
Tracking the little flies. That juice is good, man. Just need any more juice?
The red stuff, water. Yeah, those girls have
Right over there.
They like that light.
Next time I see it out of your pocket.
Yeah.
Wrong pocket.
Uh-oh.
They get zapped by this, you know. They don't want to be alive for a second.
Yeah.
Mine never falls out. It's never falls out since I had
I saw one in Walmart, one of them, it was a huge thing too. You know what I did? I was killing with fly paper. I had it come out of one of those tubes.
Yeah.
I pulled it out and I went like that with a fly knife.
Yeah.
That works really good. Anyway, this is I'll just show you basically what it does. You can see this is a coil, it's a solenoid valve here. It's a lot taller ratcheting valve, see that? Instantly I know I've got voltage current continuity. With a voltmeter, I'd have to get it out, make contact with it.
Well, I think that's what you should show them. I mean, here's how you go with the voltmeter, and
Yeah, right, if I read the voltage, I still don't know it's accurate.
here's how currently you do it. And
Okay. See, that gives you an idea, see it. Now these ice cube relays, I have this jumper here. So I can operate this one. You see what that does? If you got 50 or 100 of those in cell, and you're just looking at the end of it, you don't know. If
Well, that's, I think, to make sure to tell the story. I mean, that's the value of it. So what do you want me to do, Jess? Walk through the questions?
Let's get you first, then you can relax. Let's go through every question. After every question, pause. And then go to the next one, look at the camera, look at him like you're asking him.
All right.
Do you want a demo?
And then you can sit there and whatever you feel free to ask. But we'll get all the questions first.
When do you want to demo it?
Okay, you want to do that now?
Yeah, go.
Yeah, I could do that real quick, and then we
Okay.
can go on the questions and say,
Okay. Will you be asking for him to do the demo?
Yeah, I mean, I think, well, that's kind of what I wanted to do. I said, why don't you introduce us to the MagProbe? That was going to be the first question. I didn't get to it. Because when you said kind of hi, and then you kind of went into it, you started just telling. I was going to say introduce us to the MagProbe, and then you can do that very
Okay.
simply here.
Oh,
Okay,
yeah,
after you
right,
say
okay.
that, cut.
All right.
And then we'll get you to do all that.
the demo?
Yeah.
You want to go through all the questions and do the demo?
Okay, let's do all the questions first.
Okay.
Okay, one at a time, and then you'll be through.
Well, you could always insert it right after a question
Yeah.
later, right?
Yeah.
Okay.
Yeah, right, because I only have one camera today. I don't want to go,
Yep.
So I just want to do all your questions, and then you do.
Should the
demo.
microphone be
We'll do the
pointed
demo.
up toward me or to the side? Or
Well, because, that's tricky with t-shirts. You almost have to. Because you're talking to him on this side. Okay. Okay, we're going to go through all the questions first. After every question, give about a 3-second pause.
all right.
Stand by.
Wait 1 second. So what are the main advantages of the MagProbe over the voltmeter ohm test? Is that going to tie into the demo, or are you just going to talk about that? See, I thought that was kind of when I said, introduce us to the MagProbe or whatever. I was kind of thinking that's where you were just going to go through. Look, here's how you do it with the voltmeter. Here's how you do it with this. Here's the magic.
Okay.
So then I'm not really asking that when I'm saying,
Yeah.
kind of introduce us to the the MagProbe. Tell us how it works. What's the advantages of the MagProbe over a ohm or a volt or an ohm test?
That's a good idea. Really, that really falls in line because I can go through it real quick here. And that gives us a demo, and the demo's done.
Yeah.
Basically, right, okay.
Okay. Stand by. Okay. Stand by for the opening and 3, 2, 1.
Bob, introduce us to the MagProbe and tell us what some of the advantages are over the voltmeter.
Okay,
ohm
before you
test.
start, will you do the greetings again?
Okay, go through the
Okay.
greetings again.
Okay, stand by.
Hang on 1 second.
Okay. Three, 2, 1.
Hello, this is Dave Kalstrom from Outbound Excellence, and welcome to our series. Got
Okay, it's
the
okay.
series.
We're still rolling, so anytime.
Hello, this is Dave Kalstrom with Outbound Excellence, and welcome to our series Spotlight on Technology. And today we have with us Bob Bartol, the founder and CEO of Bartol Research, and also the inventor of the Bartol MagProbe, which is a revolutionary non-contact method of testing electrically operated solenoid valves and relays that are 99% faster than a voltmeter.
Okay, now ask your first question.
Bob, introduce us to the MagProbe and tell us what some of the main advantages are of the MagProbe over a volt or an ohm tester.
Well, the main
Okay,
objective.
cut, okay. Yeah, you don't have to answer yet.
Oh, okay.
Okay, next question.
Oh, I see.
So tell us a little bit about it. How does the MagProbe operate in humid conditions?
Cut, okay. Okay. Next.
How about as far as the environment goes, how does the MagProbe operate in extreme hot and cold weather conditions?
Next.
That's a tough one. Sometimes parts become magnetized during manufacturing. At what level of magnetism will the MagProbe detect?
Next.
When we test large solenoids and relays, the magnetic fields may overlap. Can you reduce the sensitivity?
Okay. Next.
How can I see the LED if I work outside in bright sunlight?
Okay.
How can I make sure that the MagProbe's working before I troubleshoot?
Okay.
What powers the MagProbe?
Okay.
Have your customers encountered problems with new solenoid valves?
Okay.
So the only thing we're going to do then is we just kind of tie out.
Okay, right. Okay. Now you're gonna go ahead and do the demonstration. That's a first question, right?
Yep.
Okay. Now during the demonstration and he's talking, if you want to agree, that's
Okay.
okay. I understand. Okay, good.
Yep.
But, you know, you can.
Yep.
Okay, you can do
Yeah,
that.
I'm not hitting it down.
Yep.
Okay.
So it's kind of introduces to the MagProbe. What are the advantages of the probe over the voltmeter ohm meter?
Okay.
Okay, I want you to say, because he already introduced you, just say thank you or whatever you said. I'm glad to be here or something, okay? Stand by. Now speed and go.
Well, thank you, Dave. It's a pleasure to be here today, and it's exciting. It's an exciting product that I'm proud to present to you. The main advantage of the MagProbe is speed. Typically, when you use a voltmeter, which is this little voltmeter here, in maintaining the equipment, you have to make a direct connection with these wires, and you can't penetrate the insulation in the wires. You have to go to terminal strips and use schematics. However, to overcome this, we know that if we can detect the magnetic field generated by a solenoid valve, electrically operated solenoid, or a relay, we know it has voltage, current, and continuity. And in case of a computer turning it on, we know the computer sending the signal through the wires, and the wires are okay. So we've accomplished a lot in a matter of a second or two, instead of like 10 to 15 minutes with a volt ohm check here. Whereas if you connect in parallel with this, with a voltmeter, you don't know if there's current through the coil. And the only way we can do that is with either detecting magnetic fields or turning off the equipment, disconnecting the power, turning off the computer, and then making a resistance check, which is not a good method to do. Here's a voltmeter, MagProbe right here, and we have it hooked up to a battery as a demonstration here. Here's a coil and a solenoid valve. Now what we do is, and this is the relay here, we just hold the magnet up here. There it is. You see the light turn on? Now you see it turn on and off. Now this little relay here is used in elevators and many other applications. And it's called an ice cube relay. You see it turning on and off. And that indicates right away you have voltage, current, and continuity through that coil. Now we do the same thing in the electrically operated solenoid valve, but this works on AC and DC both. It makes no difference. Which generate magnet. Now you can see that turning on, off on that solenoid valve. Whoops. There it is. You can see it turning off and off. Now that check has been taken about 1 second, and normally 2. In the case of sometimes a solenoid valve will retain its magnetism, which is called retentivity, and it should not retain its magnetized condition after the power is off. If it does, you can have an intermittent operation or a partially open or partially closed valve. In the case now of aircraft, if it's partially closed or partially open, and you have a fuel control valve, you hit a rough air, you can turn off the fuel and clean out the engines. And in the case of propeller driven, same thing, the engine's quit. But with this, you can detect it. Now sometimes these valves are manufactured all over the world, and we're not sure what the quality control is from receiving these. So you take it right out of the box, cycle it a couple of times on the bench before you install it. And then you're sure that this isn't occurring. However, if it does, like the customer said happened to him, he installed another one, he checked it and put it in, it worked. So reinstalling it worked. In the case of like I say, critical operation, that is critical. And it has many other advantages as far as temperature. Now that's sealed, so it's called intrinsically safe, which means because of the manufacturing technique, it's waterproof and it's also explosion proof. Although it's not rated an explosion proof yet, but it will be. Now in the case, let me give you an idea of humidity with it. I've got a glass of water here now. Now that's extreme. You know, when you drop it in, will it work in water? So we just dropped it in water. And we'll check it with this magnet here. See it turn on? It's underwater. There's nothing in existence that will do that underwater. Now the initial test we did with this, we took 4 of these, immersed them in a quart jar of water, and only one failed after 30 days underwater. Unbelievable. It's fantastic. So normally you don't do that. It's going to be momentary or 1 minute or 2 minutes, but in extreme, like offshore drilling platforms, that's critical. And the salt, it's not affected by salt either. So it can be used on commercial shipping in oceans, which is a major problem with salt water and contamination. But this isn't affected by that. You can see what happens here. And that was a big advantage now, if you ever wonder about if it operates, we've got this little magnet in here. I can take it out of that water. And this magnet comes with it. It's in the little tube that comes with the MagProbe. And it's in the little cap here. It's a red cap comes with it. Now, if you're in doubt, when you use it, you can just hold it up to this and test it before you use it to make sure it is. Now, in many cases, if it doesn't light, you wonder if it's operating or not. This tells you it is. You can do that during the operation and after the operation to make sure it is operation. But you can do that every time. It only takes a second, but it ensures that it doesn't fail. Now, the reason we use a lithium battery here is because of its long shelf life of 10 years. It only loses 5% of its capability after 10 years on the shelf, which is extreme. Normally, we have these in use from 3 to 5 years, and if you use it one time, at one job, you save the price of it. Say it costs $40 or $50 for one. You save that many times over in one day, at least the price of it. So it goes on for 3 to 5 years. Imagine what the profit margin is when you test the valves with this. Now we have the little red, this little black tube. Now an oil company called up one day and wanted to know how we can shield it against the sunlight. They were making tests outside of the north slope of the oil companies of Alaska. And they said, well, so they wrapped the electrician's tape around the red cap and looked down the tube to see it operated. Is there any way it can do that better? And we don't want to do that every time. I said, sure. So we developed this little black tube. And it fits right over the red cap. Now when we're outside, we can see it. It shields it from the sun, yet we can still maintain the operation of it. You can see that as how it operates. And that solved that problem. What's nice about it, it only weighs about 3.5 ounces, and it's 3.5 inches long and about 5/8 of an inch wide. But because of its size, you can put it in the shirt pocket, button your pocket, and there you go. When you need it, you take it out and use it. Now, like I say, in Alaska, they were using it at 80 below zero, but its specifications at -40, so you've got a lot of leeway. You could go all the way to -80. In fact, the engineer in the oil company said, I've got news for you, the wind chill factor was -125 degrees and it still worked, which absolutely shocked us too. Because usually, with any material you have a glass point, and it gets so cold it shatters. When you hit it, it shatters. It's just like ending free. Now, if you ever excuse me a moment, I dropped this cap, this red. This little white sleeve has an anti-magnetic shield over this tip to protect it when you're not using it so it doesn't turn on. When you use it, you take it off. However, if you want to increase the sensitivity, use the little magnet according to the instructions, which increase it from just 3 Gauss to 1 Gauss sensitivity, which is unbelievable. Well, you get down, some units are sensitive to detect the Earth's magnetic field, but we don't want that, so we don't sell those. But this tip now is shielded, so it's used for 2 purposes. If you drop it, it protects the tip from breaking. You remove it, it becomes sensitive. But in the case of large solenoid valves that are big ones they use in oil companies, sometimes the magnetic fields, they sit next to each other and the fields overlap. So when it lights, is it picking up this one or this one? So what they did, they just slid the white shield over to decrease its sensitivity so they wouldn't detect the one next to it. And it worked perfectly. Now that came from a customer. He said, I'll just do that. I'll just reduce the sensitivity for the large ones. when it worked. So we put that on each one of the units, and it comes a little too with the instructions with it.
That's, okay, that's a demonstration?
That's it.
Okay, go ahead and ask the next question.
I know the thing is within the demonstration, we just overlap like
He's
half of
already,
the questions,
oh, you already answered the questions?
like half of them. So now we don't know whether we're going to splice the questions in with what we have, or we just
I see
answered.
what you're saying.
We answered the light one. We answered we answered the humidity. We didn't really touch on the temperature, but we did kind of. So it's so if we're going to do it the way we got to do it, then we're either going to be redundant in half of the questions, or so almost got to do the. So the first thing, I mean, I think just a lot of that stuff we should just that we don't have, we move, and then as we go to the questions. So really, that should be just really talking about how it works, and then the difference between that and a voltmeter, and then stop. And then what we should have done is we regroup for a second, and then the next one is how about humid, how about hot and
Oh, I see
cold.
what you're saying.
So we talked to Alaska, so you're going to be in there trying to splice it.
Figuring out what's, yeah.
So that's going to be very, very difficult. But you know what? I mean, that's the beauty of just sitting here. And then we talked a little bit about overlapping the magnetic fields, but we didn't talk about the powering or the problems with new solenoids. So, I mean, we could do it a couple different ways. I mean, really, we could use that as an introduction into it. And then that would be one video all by itself. That's just an introduction into it. Because that's really what that was. That was the overview.
Okay, and then go back and ask questions or what?
Well, no, but I mean, that was one. Whoop, just keep that snapshot as one video. And we have like 3 videos. This is more of an interview.
Oh, okay.
That would just be on the website. If you want to see an overview, that would have been an overview.
Okay, that's one.
That would have been all the
that's one
important
segment.
stuff.
Okay,
Yep.
fine. Okay, so what do you want to do now then?
Well, I mean, now if we were going to more do, make sure that we touched on all the points, because a few points we didn't touch on, but that would be a good overview. That could be the normal overview button. This would be like an interview, you know, where he's getting interviewed, but we'd go back to just do the test between that, show how it works, test between that and the voltmeter, whoop, stop, and then kind of like you said, then let's regroup for a second, right? Okay, now let's go, what was the first question? How about humid? How about hot and cold? How about magnified? Right? You know what I mean? And then
we covered that residual magnetism.
Well, no, but you did. But see, the difference is what he was waiting for you to do is just do one stop, do another stop, do another stop.
Okay.
Now we got it all bundled together, so there's no way to insert the questions.
Okay. Okay. Well, we can do. Here's an idea too. We can do that. Keep it as a segment, as a demonstration. You can ask the question. I don't know how you want to do it. You can ask the question, pause, and then you just answer it. Pause. Ask the next question. So I don't go back and forth like this.
Yeah. Well, I think you have the questions were perfect. I think all we have to do now is just go back and say, before we start, just remember, all we're doing right now is we're giving a brief introduction of the unit and how it compares to like a voltmeter.
Okay.
Then stop.
Okay.
That's the part that we didn't do, right? Okay, let's just make sure we're all communicating. Then you're going to stop. Okay, pause. And then we'll talk for a second. Okay, now the next question is about the humid. So, you know, are you comfortable where you're going to pick up with the humid? And that's where, I mean, now we could have not had the glass. Now get rid of the voltmeter, get rid of the, you know, whatever we can get rid of. And now it's just the glass,
Okay.
right? You know, so we're focused. We don't have a bunch of junk there that's not relative
Okay, I see.
to.
All right. Okay, so where do you want to start from here then?
So I would say I'd move that.
Yeah, eliminate some things.
Move that glass. I mean, the voltmeter is important here. I mean, the thing that you're really going to do is, I mean, to me, it's a thing like this. Look, currently, I mean, this is the way that I'm hearing the story. Currently, right now, look, if you're testing a solenoid, you got the positive and the negative, you got the thing here, you got to physically contact both these things, and then, you know, as you know, on the dial, it's going to show. Okay, throw that away. I mean, move that, you know, set it to the side, so now it's just clean here, and the glass is in here. The difference between this, first of all, as you know, it's non-contact. So non-contact means that in order to use this, you have to open up the panel. See that thing that you said, all those wires are behind this panel. You got to open up the panel. Then you got to pull, you got to get behind this. You got to touch these things on these 2 things. And you got to do that for a panel of 50 things. With this, is that panel of 50 of them. You put this thing in front of them and goes good, 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 good. That's the one that needs to be. This takes about 5 to 7 minutes per cube. There could be 50 of them in there. This takes about 1 to 2 seconds each. When you look at it from a profitability and from an efficiency standpoint, wouldn't make any sense to do it the other way. So that's kind of, you know, what I thought. And then boom, that's kind of the, okay, now I see what it does. Then would get into how about humid, how about cold, how about, you know. So that's what I was. I mean, what's the value of it? The value of it is that it takes long, it costs a lot of money, it takes long, you got to get behind the panel, you got to, doesn't that all make sense? Yeah, everybody's like, ports, that makes sense. That's exactly how it does. That's not how it works anymore. How it works now is just this. You got a bay of them, you're just going to put this thing next to them, it's going to go bad, 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 but good. That's it. That's the one. Fix it. Swap it out. Go back to work.
That's a good point. Well, that's right. What you said there, and I forgot to say it with this, you can detect 10,000 a second. So if you lose the power for 10,000, you can see it with this, you can't see it with a voltmeter.
Yeah.
And besides your direct connection, you can't stab the wires because you destroy the insulation. You have to go to a schematic and trace it back to its terminus.
So I'd say take that glass and then move it to the side because we're not on the water piece.
Okay.
If you don't really need the sleeve right now,
No.
you don't, I mean, if you need any of those to tell the story, but like that white piece, that's the magnetic overlap, right? So that's not even right now, is it?
No.
All right.
So
So
you do this.
yeah, but we're going to come back to that, right?
Yeah.
But I think the magnet and testing, but I mean, for right now, this segment, remember, we're going to keep stopping. So this one is just strictly, look, here's how it's done today, and here's how it's done with the revolutionary new way. And then when you get done with that, stop.
Okay.
Not hot, cold, wet, wild, nothing. Just,
Okay. Okay. Go right to him then, no questions?
yeah. Well, because the question's going to be, and I said that originally, introduce us to the MagProbe. So this is the answer really to the first question.
All right.
Are you good?
Yeah. Let me show you this here.
And I'd make sure they understand, and bring everybody into the confusion of the wires and the panel and getting back, and you're holding the thing, and you know how that long. It could take 5 to 7 minutes, or it could be a bay of 50.
Well,
You could spend an hour and a half embedded in wires with the volts test and that. You're
You're
talking
right.
2 seconds each, go up and down the bay.
Well, you open a panel of these, and it's just thousands of wires all over it.
See, and that's what I mean. That's the story that I would be telling is, I mean, you know what it's like. There's thousands of wires back there.
Okay. Ready?
You want me to just go right into the...
Yeah, because I just asked the question.
Okay.
Bob, introduce us to the MagProbe and tell us a little bit about the main advantages of the MagProbe over a volt-ohm test meter.
Okay, that's a good example of this relay, though.
Yep.
They are terrible.
Okay, stand by. And the question's already asked. And 3, 2.
Thank you, Dave. Well, the main advantages are speed. And if you look at this little relay here, it's an ice cube relay. Now, these are used throughout industry. And the example I have here to give you is with elevators. There may be 50 or 100 of these in one elevator, and when you open the panel to test it, it's just thousands of wires to test, to check. If you do it with a voltmeter, how would you find the correct wire behind it? You have to go to a schematic and find out wire number so-and-so on such and such a relay, but you see all the little contacts behind you. Now you take the voltmeter and you measure the voltage. Now you read a voltage if you get that far. It takes a long time to find it on the schematic and then check it, and you take a reading. Even if you took a reading, you don't know if there's current through the coil. Now if you take a voltmeter, a MagProbe, you hold it right up to the relay. There's this, can you imagine 50 of these together with all the wires behind them. There's a panel right in here. And behind this panel you look and there's all these thousands of wires. Now I want to check this relay and see if it's energized. Now you see that light come on? Right there. That's what it takes. That's how long it takes. Just a second. And once you get the spot on all these little ice cube relays, you know where to go on each one. Now I'll check it in 1 second, where it normally takes the voltmeter, and still, even if you get a voltage measurement, you're not sure you don't know if there's current through the coil. If you wanted to do that, you'd have to completely power off the elevator and pull a relay out and make a resistance check across the coil, which is not good because sometimes you can detect a resistance in it, which is correct, and then you plug it in with power and it opens. It doesn't work anymore. It breaks the circuit. But with these ice cube relays, it's specifically that illustrates what it can do. So you've eliminated the downtime of an elevator from anywhere from 20 minutes to an hour to make sometimes 2 hours to find the problem. With the old method, with this, you do it in 1 second.
Okay.
Yeah, now we got it.
Okay.
Okay, so now, yeah, regroup. So now I would say let's get rid of this
Okay.
and let's get the glass of water. And is that really blocking? That's not too much blocking. How you can bring it off to the side now.
Yeah.
So the thing is, the question is, will it operate in humid conditions? And I'd say, yeah. Will it operate in humid conditions? Yeah, that's a good point. I can give you a real dramatic, that's what I would do. I mean, he did really good on the other one because he talked about all the value. I mean, it was just all about value, the wires, the hassle, the time. So it wasn't about the MagProbe and me and the voltmeter. It was just about value. And that's kind of what this is too. So just remember when you're out there, if you're out in the water, if you're on an oil rig, kind of like you said before, where are you when you would find this value? And just keep focusing on the value. Value is this.
I'll just focus on the waterproof on this.
That's all it is.
Okay.
So the question is, will it operate in humid conditions? That's a good question here.
This is really dramatic.
Yeah.
I get it.
Ask him, would this be humid? Would a glass of water be humid enough? This would be the equivalent of, say, people working on an oil rig where they're actually submerged in water, not only water, salt water.
Oh, yeah.
I mean, that would be good because it gets, the energy in.
Okay, sounds good. Okay, the question's asked. Stand by. 3, 2.
Well, to illustrate whether it's waterproof, I have a glass of water here, and you can see through it. Now let's assume this is clear water, but it can be salt water, and this is not affected by salt water, which is especially valuable to the offshore drilling rigs in the Gulf, which we sell too, and they like it because of that. Now let's check it to see if it's waterproof. I'll just drop it that glass of water, and I'll operate it underwater with this magnetic. This is a small magnet. And I turn it on and off underwater. So that takes care of that. But you have to remember that it also is, since it's waterproof like this, it's totally sealed. In fact, it's double sealed inside of here. And the tip that operates inside of here is in the vacuum, and it's sealed. So there's no explosion at all, possibility with this. And that makes it intrinsically safe for explosions.
Okay.
I think the only thing that was kind of cool when he said before is you had, and they were, 30 days at the bottom of the ocean or whatever, or 3 of them or whatever. I mean, that was kind of like a powerful one. I think I try and just do that. I mean, just pull it out real quick, wipe it off. It won't take a second to go through that. But I mean, that's a powerful.
Okay.
Yeah.
Do it again.
Yeah, I would say, hey, let's see how humid resistant this is. Boom, drop it in the water.
Yeah, that is a good point.
Yeah.
You're right. You're right. Well, I forget. I go through this so many times, but when the customer sees that, they'll go. The jaw drops. And, what? 30 days underwater?
Yeah. No. It's very powerful.
Yeah.
Okay.
Okay. Questions asked. Stand by. 3, 2.
Well, Dave, you asked if it would work in humid conditions, but not only, let's assume that's salt water, and this is an extreme humid condition. Now, I drop it in this water, and in our initial test, we had 4 units in a quart jar of water. We dropped the 4 units in, and we watched them every day until finally one did fail. And the first one failed after 30 days immersed in salt water. But it can be fresh water, but in the case of the offshore drilling rigs, they really like it because it doesn't react to salt water or to chemicals. By that measure, it does not. And you see this operating on and off underwater.
Okay. Okay.
Yep. So the next one is, how does it perform in extreme hot and cold weather conditions? So,
Okay.
I'll move that out of there.
Here, I'll get it.
That's a good test too, because it came right out of Alaska when they told me.
Yeah, no. It's
Okay.
So how does it perform in extreme hot and cold weather conditions?
I'm also recording your audio right now, just so I know
Okay.
what question.
Yeah.
Just making sure I'm on the right question here. Okay. Are you ready? Okay, stand by. Questions asked. 3, 2.
Okay, that's a good question because we did receive a call. I received a call from Alaska. In fact, the north slope of the mountains up there. They said the temperature there was 80 below zero, and it operated 80 below zero. And I said, well, the specification is 40 below zero, but I'm glad to hear it works at 80 without any problems. But they said not only does it work at 80 below zero, but we have a wind chill factor of minus 125 degrees. Now typically, material has a glass point. When it reaches so cold, it shatters, and it didn't. So there it was at mine. But he said we do normally keep it in our pocket and then pull it out and use it, but at minus 80. In our initial test, we put it in a cold chamber, and the cold chamber was 80 below zero. We did that for 7 days without any problems, without a failure. Secondly, we then put it in a hot chamber, which was up to 160 degrees Fahrenheit, and it worked without any problems. Now, typically in testing materials and instruments, if you, they call it thermal shock. So we did a thermal shock, which is the ultimate and extreme shock, where you put it in, say, 10 below zero, and then bring it out and put it in 110 degrees or 100 degrees outside. That's the thermal shock. Now, if anything's going to fail, that will certainly kill it, because it's a tremendous shock to the material used inside and outside of it. But it survived the thermal shock test too, which is very, very satisfying to see that. So we expected plus 160, but actually our test went up to 180. I didn't want to cook it, or bake it, but we wanted to have an extreme temperature to make sure we didn't have any deformation of the material, and it didn't. Everything survived perfectly.
Okay.
Oh yeah, no, this is 1,000 times better. So the thing is sometimes parts become magnetized during manufacturing. At what level of magnetism will the MagProbe detect?
Okay. Stand by. Questions asked. 3, 2, 1.
Well, typically the sensitivity of it is 3 Gauss as it stands here, or better. If we use the little magnet that comes with it, we can adjust that down to 1 Gauss, and in many cases less than 1 Gauss. But if it's so sensitive, if it picks up the magnetic field of the Earth, we don't want that. So we don't sell those, but we do have that happen occasionally. It's rare, but it does happen, where we can actually detect North and South poles of Earth. And the closest competitor to us, well, if there was any, but after what it does, but their sensitivity was 300 Gauss, and ours was 3, which is 100 times more sensitive. But then when we put the little adjustment magnet on the tip of it, we got to 1 Gauss, which made us 300 times more sensitive than they are.
Okay.
Perfect. Okay, sometimes parts become magnetized during manufacturing. At what level of magnetism? Is that the one that's one we just did, right? Okay, when we test large solenoids and relays, the magnetic fields may overlap. Can you reduce the sensitivity?
Okay, questions asked. Stand by. 3, 2, 1.
Yes, we can. This came about with a company, I think it was oil companies and a drill, they were doing refinery. But they had in a refinery these very large valves, they're huge, and they generate large magnetic fields. Well, they do interfere with each other sometimes. They overlap. Now, if we tested one, how are we sure we didn't test the one next to it when we picked up the magnetic field? There's 2 ways you can do that. They move from one to the other, and you see it go out and then on again to the next one. You can do it this way, or in this case, the customer said, look, this reduces the sensitivity of the MagProbe to prevent it from turning on when you're not using it. And it also prevents damage when you drop it, because it bounces. So, since this will decrease as a magnetic shield, it decreases the magnetic field when you apply it to it. Now we've decreased the magnetic field, and we don't use it, we're out here. You see that? It becomes out here to down here. There it is. And he said that worked. It eliminated the overlapping magnetic field. And that's really essential, because you have that lithium battery, you don't want to turn it on when you're not using it. But it's clears about it in the instructions to not insert it into the tube with the magnet down. You put the red cap, hits it in the tube, and it won't turn on. But that's clearly illustrated in the instructions.
Okay.
Okay, how can I see the red LED if I work outside in bright sunlight? Make sure you remember the camera's there,
Yeah,
so
okay.
even here.
Can you move slide on the wiring just
yeah.
a little bit? Just okay, thank you. Okay. Stand by. Questions asked. 3, 2.
And this came in reply to one of our customers that used it in outside activities such as oil companies and chemical companies and plants, but they have valves outside of the environment inside where it's so shielded from the sun. So what they did, they said, well, the LED is kind of hard to see, so what they did, they wrapped electrician's tape around the red cap and looked down the red cap to see the LED. But we don't have to do that to every one. So I said, what can you do about that? So I said, well, we'll just develop something to shield it from the sun, yet we can see the LED. So every one is equipped with this black tube. And the black tube is very simple. You take it out of the box, slides right over the red cap, put it down the magnetic field, now we can see it. We can look down the tube when we're shielded from the sun, we can see the LED has no problem.
Very nice.
That solved that problem.
Okay.
How can I be sure it's working before I troubleshoot?
Okay, stand by. 3, 2, 1.
Well, not only does this little magnet increase the sensitivity, and also, by the way, it will identify north and south poles when according to instructions. But if you're using it, the main problem technicians have, if the light doesn't turn on, let's say we hold up to test this, and the light doesn't turn on, how do we know this works? Well, we go to the little magnet that comes with each one, and it's in the tip of the tube, and we can self-test it, like this, real quick, go back, test that, well, now we know it works. Because anything can all of a sudden fail a battery or destruct, through physical damage. But with this way, you're sure it works. That is one of the major problems with any test instrument. If you don't read a voltage on the voltmeter, you know the voltmeter works. Well, that's hard to test unless you check a voltage with it. But with this, you can check it every single time if you want to. And since these last for 5,000 5-second tests, which is in many cases 3 to 5 years, it's definitely worth it. Every self-test, we self-test every one at least 5 times during manufacturing, make sure there's no defects.
Okay.
Okay, what powers the MagProbe?
Okay, stand by. 3, 2.
The MagProbe is powered by a lithium battery. And the reason we selected lithium batteries was because of the long shelf life. Typically the shelf life of a lithium battery is 10 years. After 10 years, it only loses 5% of its capability. In other words, you still have 95% of its capability left after 10 years on the shelf. So in between usage, it'll last and last and last. The more you use it, the shorter the lifetime. But it's so long now that we even have some units out there 5 to 10 years. And besides the lithium battery, it has a rapid, when it's expired or discharged, it drops off rapidly, whereas a regular alkaline battery is a slow curve. If you mean, in other words, it doesn't just drop off like this, it drops on a slope like that, so it can be intermittent, sometimes work and sometimes not, but not with the lithium. When it quits, it's a very sharp decline, and you don't have that intermittent application. So then you can buy another one or use your backup unit when that occurs.
Okay.
So I think the only thing that would have been interesting to know there is like how do you, it looks like that was sealed and you put it in water. I wouldn't think that I'd be able to replace the battery. So it kind of like puzzled me. How are you able to do that? It unscrews at the red, from the red to the blue?
No, it doesn't. It's not replaceable.
It's not replaceable.
No.
Oh, I thought you just said either replace the lithium battery
Oh, no,
or...
I mean, replace the whole unit. I'm probably wasn't clear.
Yeah, that's what I heard, yeah. I thought it was a battery. So
Yeah, you said either replace the battery or use your backup unit.
Okay.
Okay, you want to say it again?
Yeah, I'd do it again.
Okay.
Let's see, what's here? A shelf life is 10 years. After 10 years, it loses 5%, so you did all that. A relay is 2 seconds, so you know all that stuff and you did it. Yeah, that's the only thing that I was wondering, because I was thinking, wait, I don't...
Okay.
But you know what? It brings in something though that I think in the frequently asked questions or whatever. How long should that lithium battery last? Did you say like up to 10 years?
Yeah, well, it lasts a 5,000 5-second test, but the normal test is like 2 seconds. So, but typically in the field, the experience we have is anywhere from 3 to 5 years if they don't abuse it.
So you know what? I think to be honorable, because that would be the one where somebody would say that's the downside of this. Look, I use it till the lithium battery's done, I got to throw it away, I got to keep buying new ones of these. I only have to buy this voltmeter once. I mean, that's the one thing you got to remember, like when you do social media. You can't, there's a reason you pay $40 instead of $400, right? You know, and there's a reason for it. And so you got to make sure that you're not afraid to tell them the reason why. There's pros and cons to it, right? If you wanted to spend 135, or if you want to get back the wires, you can do that. Yeah, at the end of the life, because it has to be sealed. So the thing is, I would tell them, look, because it's sealed, to keep it hermetically sealed again, you're not able to replace it. But let's make sure we're all on the same page here. 5,000 tests over 2 seconds at a time. The average life of this would be 3 to 5 years, right?
Well, you know, my answer to that is use it one day and you save the price of it.
Yeah, well, however you want to do it, but I mean, I think this is important to, because, you know, when there's a frequently asked questions, I mean, you know, hey, how long does it last? Or, you know, people are going to have to try and pick holes in it, so the only hole that I've seen so far is, you know, this thing, you know, the battery goes bad, you got to throw it away. What if it came with a bad battery or a weak battery? I mean, I use it for 2, you know, then you could come back and say, well, you know, we warranty this thing for, but that's the only thing I've heard so far where anybody could ever shoot holes in it, right? Is that, you know, okay, so you get done, you got to throw it away. After 3 years, there's new technology. You would want to throw it away. In 3 years, I'm going to have one 10 times better than this. But it's just, at least it's there that it has to be addressed.
Well, that's how I answer it. I've been asked that question, and they said, well, I can't replace the battery. I said, no. But if you use it one time in a service call, I might say 2 times. You save the price of it. From then on, you have 3 more years.
All right. We're ready.
Okay.
Well, it's very good. Well, that's why I like doing it this way, where we stop and put our thoughts into it.
Well, that was a good point, Richard, made it, because I was asked that question.
Well, no, of course. I mean, everybody's going to try and, somebody's got to go out there and try and discredit you. I mean, not discredit you, but try and offset the value and replace your value with their value. And I mean, so far, I was going to say that's going to be a pretty hard task. This is the first thing I've ever heard that we had anything to work with.
Okay.
Anything.
Okay, same question asked. Okay, stand by. 3, 2.
The MagProbe uses a lithium battery due to this long shelf life, which is after 10 years, it retains still 95% of its capability. However, it is sealed in here, and the battery is not replaceable. Now, it's done this way to be intrinsically safe from explosion and also waterproof. If we didn't do this, it wouldn't be. However, once you use this, the time saved, when you check all these little relays here at solenoid valves in 1 second or 2 seconds, you save the price of this when you use it 1 day in service calls. 1 day. Now you have 3 to 5 years left, or 5,000 tests, which are thousands and thousands of tests versus the voltmeter that you're going to be making money.
Cut.
Yep.
Okay. Any other thing?
Man, I think the only thing on that, Bob, I mean, I would have just, I think, you know, there's so much to be said right here, you know, when it gets back to the value. I mean, now's the time to really, what's nice about this is you're taking an attack and you're you're taking an attack and you're laying it on somebody and you're crushing them with it because you're telling them, look, I mean, let's put this in perspective. Yeah. The average amount of time it takes to, you know, that thing where you said you've paid for it, that was kind of like, who paid for it? Wait a minute, you haven't told me how much it costs, so I mean, how do I know? But you know, it's like you have such a powerful opportunity, not that we have to replay this, but I mean, the next time somebody asks you, just say, I mean, that's the whole beauty of it, the value, right? I mean, the value of this compared to, yes, intrinsic, you can't replace it, or else you wouldn't be able to drop it in the ocean, and that's how come it's, you know, it's zero, you know, explosive, you know, ... like this. But keep in mind what the value of this is, because this really now highlights the value of this compared to a voltmeter, and then you really get into, if you had a elevator, you know, I like where you had that story. You shut down the elevator, it's 2 hours or whatever like that. That 2 hours, that shutting down the elevator, your tech time out there of 2 hours, this thing could be done in probably 7 to 8 minutes.
Oh, easy.
What's the cost of the technician's time for 2 hours every time you go on an elevator service call? You know what I mean? I mean, it's a powerful time to because all of a sudden you start doing the math. How many service calls does in a technician go on in a day? If they went on 2 of them a day in 256, say you went on 500 calls, and you say that would be 1,000 hours. What do you pay your techs? And then you know what? I just sit there and stare at the camera and say, while you're doing the math, how much would it cost to on 1,000 hours of text time if you say by having 1 probe? Look at the camera, and that would be like the fade out of that one. It's like chew on that, Paul.
Yeah, your point was perfect, because I got a call from Otis Elevator out of Canada one day, and the guy called me and he said, you know, we did a valuable test on this. We had a big strike in the elevator industry in Canada. So the supervisor had to go out and do the work. Well, that opened a lot of their eyes, so one of them said they had 2 of these in their drawer and they got them out. He said, well, they've been in our drawer, why do I have to try this? And because we're not up on the techniques ourselves, right?
Yeah.
They picked it up, they went on troubleshoot the elevator, they called me and they said, listen, let me tell you something. He said, we did a cost analysis on what this saved. And he said, for every one we bought for 40 bucks, we made $10,000 more per year. Per certain
I'm telling you, that's you got to replay that segment. That's the story you got to tell them. You got to tell them the thing about the lithium, and then you go, but you know what? I'm glad you brought up that point, because this is a great way to basically emphasize the value. The reason you want this more than anything else, it's a lot more technically, the non-contact, the non-explosive, the submersible, but when it comes to value, there's nothing like it on the market. Let me give you a testimonial that we received, and that will, you know, exemplify the value of this thing, and tell them that story.
Yeah.
For every one that we have, it saved 10,000. Eat that.
Yeah, you brought.
Yeah, right.
Yeah.
No, you brought that
No, I
down.
mean that'll rock their world.
Well, you really hit it right on the head when you said that. That triggered me thinking about the
Yeah.
conversation with Otis L, but I can't mention
No,
Otis.
let's say we had a
Yeah. Okay, you want me to take that?
recent, you know, hey, case their testimonial of one of our premier elevator in the world. You know, I mean, just however you want to introduce it, but no, tell them the thing about the 10, each one basically save $10,000. And say, I would say a company of this size probably has in a range of probably between 50 to 100, and each one saving them $10,000 each.
Oh, easy. Yeah,
Look at the camera.
Okay. Well, you want to go back to lithium, guys, or just
Yes. Start with the battery, but then you know when it gets to the part where you said, you know, yeah, you can't replace the battery at a point of probably the lithium life is 10 years. If you were to test 6,000 of these, you know, on an average, it probably lasts 3 to 4 years. But let's talk about the value, man. I mean, just bam,
That's a good.
because that's where they'd attack you on it.
Yeah.
Oh, that's just, you got to throw that stuff away. You keep replacing them, you know, and that's all that sticks in people's minds. Oh, no. That you have to throw them away. That'd be like every 3.5 years, right? But let's talk about value as long as we're here.
No, that's a good point. You brought that out of me when I'm about to
Yeah.
go to this elevator. And when they said that, I was shocked so were they.
Yeah.
I think I ship them to Canada all the time, man. They want it bad. They call up, can you ship them next day here and all this
Well,
stuff.
can you imagine calling the elevator companies in Canada and telling them the Otis elevator story? But it's the truth. You can tell it.
It
You
is.
can't publish it, but you can tell the truth to anybody you want. That's the beauty of the truth.
Okay?
Okay, yeah, I'm ready.
Okay, this is answering the last question.
In lithium battery.
Okay, stand by, everybody.
What powers the MagProbe?
Stand by. 3, 2. You know, wait a minute. One second.
The mag,
3, 2, 1.
the MagProbe is powered by a lithium battery. Now, the reason we select a lithium battery is because of its reliability and its long shelf life of losing only 5% of its capability after 10 years on the shelf. But aside from that, along with that, is a typical alkaline battery when it discharges not really slowly across the operational point, and when it does, you become intermittent. Now with a lithium battery, when it quits, it just shuts right off completely. So you don't have this intermittent operation. But the question was asked, can I replace the battery? And I said no, because we would lose the capability of operating in environments of...
Wait, hold on one sec. Very, very important. When you talk about the lithium battery and the lifetime like that, you got to tell them about the number of uses.
Oh, okay.
Then go into throwing it away, because then it's a progression. It's a logical thought process. But first, we got to kill this fly, because
Yeah, I know, that one got me.
I know, and you can see it right there, and it's buzzing in your face. And let's see if that hombre is, you know, it's attacked with his light. Done?
Yeah, this is, yep, we're done.
All right. Anybody want some fried flies? Or
Is that what these are?
got some peanut? Oh, in that bowl. No, that's how they cut costs. I mean, it's a great way to
What did you say?
cut costs. Those are the flies. And
Oh, okay, yeah, okay. Right.
Well, they said put that in the can.
Okay, stand by. Last question asked. Stand by. 3, 2.
The MagProbe uses a lithium battery. The reason for lithium is its long shelf life of only losing 5% of its capability after 10 years on the shelf. But importantly also is an alkaline battery discharge at a long slope. When it crosses the discharge time, it may become intermittent. And sometimes it works, but with a lithium, when it quits completely. Now I'm asked, well, can I replace the battery? I say no, because it's been designed to be totally sealed, to be intrinsically safe from explosion-proof atmosphere, explosion atmosphere. But it also works in humid climates. But when you consider that this will operate for 5,000 5-second tests, which translates into roughly 3 to 5 years, and each time you make a test, it takes only seconds. Now we had a customer call us from Canada in the elevator business, and he said, "You're not going to believe this, but we had a strike up here, and the supervisors had to start testing the elevators. But they had a couple of these in a drawer that they hadn't used yet, and they thought, well, we'll just give it a try." Well, they did, and they worked extremely well. So they called us, and they said, "We put these into service, and after evaluating the savings, what we had, how much profit we made more, we found out for every one of these in service, we made $10,000 more per year for every one. And we have all our technicians have these now. And if they last 3 to 5 years, it takes about 2 seconds to make a test. You're talking about 10,000 more profit per year, per unit that they place into service."
Yeah, it's pretty hard to shoot holes in that. Have your customers encountered problems with new solenoid valves?
Okay, stand by. And 3, 2.
Yes, they have. And what happens is when you test a solenoid valve, you test the coil, and inside of the solenoid valve is a little metal rod, that moves up and down as it's activated or open or closed. The critical part is when they're turned off, they should become demagnetized. If they're not, they can kind of float on-off condition, or not be completely off or not completely on. Now, when this happens, just for example, if you're in a rough air in an airline and you have a solenoid valve that's still partially off or on, and you hit rough air, it can go off and on, which can also cause flame out or cut off the fuel to not only jet engines but all engines in aircraft. And so the way we check it, a customer called me and said, "I have one on I'm testing now, and I'm testing a magnetic field, and it isn't on with power." I said, "Well, where is it? Turn the power off, make sure it's off." He said, "It's completely off, it's not even connected, it's laying on the bench." So when I tested, he said, "I'm still getting, I'm reading." I said, "Well, you shouldn't be, because that core in that solenoid valve isn't completely demagnetized." So we did a further test on there, and he said, "Well, what I did, I took this one, left it on the bench, pulled another one out of the box, and it didn't test for this magnetic field with it off. So I cycled it several times, tested, and it was completely turning off magnetically. I installed it and placed this brand new one. I tested, and it worked. So it told me that it was partially turned on, even when the power was not applied."
Cut.
So all we're going to do is, do we need anything to do for the fade out? Just,
Okay.
Hey, thank you, Bob. I really appreciate
Okay,
it.
okay, after you say that, don't move. I'm going to get some reaction shots of you looking at him. So every once in a while, I'm going to just come down and hit a green or amaze or whatever. Okay, so do you want to do the close now?
Okay, let's see real quick.
I can't stop moving.
All right.
Okay, stand by. Okay, how are you going to start this?
I was just going to kind of say, you know what, Bob, that's really fascinating. I mean, it really sounds like
all right, that's good. Okay, just make sure you look at him and communicate. Okay. Stand by. We got speed. 3, 2, 1.
Thank you, Bob. I mean, it's really a fascinating device. I mean, it's really kind of what we're here to showcase technology that really is moving, in dramatic stages ahead of current technology, and it certainly sounds like the MagProbe is one of them. And I really thank you for joining us. This is Dave Kalstrom with Outbound Excellence on the Spotlight on Technology series. Thank you for joining us.
You're welcome.
Cut. You like that?
Yeah.
Okay. Don't move. Now go ahead and look at him.
Okay.
You know, he's doing the close and just look at him, you know, thank you.
All right.
Nod your head, you know. We appreciate the time. Okay? Go ahead. Yeah. Just look
Thank you
at
very
him.
much, Dave. It's my pleasure. to be
No, you
here.
don't have to say anything.
Okay.
Because
He
he's
just wants us to
talking
get
right
the
now.
eye contact.
Yeah, just look at Dave. Nod your head, thank you, kind of, you know.
Love and
thank
kiss.
you. See, this is just, yeah, just reaction shots.
Dave smiles back.
Yeah.
Yep.
Smile back, Dave.
I'm smiling.
Okay, the last thing you say is thank you, so,
Okay,
go
ready?
ahead, yeah, go ahead.
Thank you
Say
very
that.
much, Dave. It's my pleasure to be here, and it isn't often that we have this opportunity to present our new inventions that are revolutionary in any field. I really appreciate it, and thank you very much.
You're welcome.
Cut, okay, now we need some reaction shots as he's demonstrating and
Okay.
talking. Okay, I'm just gonna let it roll, and you just keep, I got 5 minutes. I'm just gonna keep it on, I'm gonna use it here and there. Okay, it's rolling.
Wow. That's really fascinating.
Okay, I'm gonna let it go for about a minute, so just
Yep.
give me just a bunch of things, you know, move your arms, whatever.
Yes, there's so much.
Yeah,
Benny Hill, he's proud of you.
that's good, that's good.
Yeah.
About another 35 seconds. Okay, now do something with the arms. Okay, sit back and different position. Thank you. Anything? Looks good, looks good. Yeah, that's good, Dave. About another 10 seconds. Okay. And, yeah, that looks good, I like that. And cut. Okay, now I need some shots of you just looking at him, asking the question. You're not doing anything yet, okay? Just look at Dave. Just, for about, I only need about 15 seconds. Look at Dave, not at me.
Comfortable?
Remember your bonding.
This is funny.
Yeah.
It's a bonding look.
Okay, and you don't have to laugh. You don't have to laugh. This is serious.
No, I know we're trying
I
to.
know.
Holy
It's-
back.
We're trying to pretend Steve's
Okay,
not
I've
there.
got 3 minutes left, so
All right.
I need about 20 seconds of listening to the questions that Dave's asking.
Deep pondering.
About another 8 seconds. Just look at him, just listen to the questions.
This is an amazing picture.
And cut. Okay, that'll work.
That's it.
Okay, now one bonding picture.
One bonding picture.
What does that mean? Okay, anything else before we shut down?
No, I mean, that'd be good. You know, from there we can
Okay.
take clips out if we want.
Okay, and
Want to take a picture, Steve? Steve,
hold
want
on.
a picture with
Yeah.
us?
No, I don't want a picture.
Yeah, no, Steve.
No,
Come
no,
on, you're
you're-
involved in this.
A picture of what?
You and me and Dave here.
Yeah, all three of us
Yeah.
in the, you know, just so we can reminisce back. Give Jesse your
Now,
phone.
give me
Let
the
him,
camera.
give Jesse your phone. Let him.
Hey, Jesse.
Okay.
Mm-hmm.
And what are my questions?
I don't know, man. You're the
You know, it's funny when we did
Hey.
this, when I was on TV
Right there.
here in Phoenix some years ago.
Look at my phone,
So
look,
we sat there, we
look,
did
look at my
I was on
phone.
with,
Nah.
Look at everything.
Yeah.
Just
We did a
press
thing
that.
on called Public Response. We did this thing.
Oh, someone's calling.
Yeah.
And I was on with Ted Knight, I don't know if you remember him. And what's his name?
Can I call you right back?
Rita Davenport. She didn't know.
All right, bye.
Yeah.
It was on Rita Davenport
Wow.
show with him.
Alright. Alright, yeah, it's just a thing like that. Show you that.
Yeah, no, it turned out good. I'm glad we got that done.
Yeah, good. I don't have to have tight shots because I got your tight shots as you're
Do
demonstrating.
you? Okay.
Because after I started demonstrating, it's not going to do me any good just getting tight shots. The demonstrations are better. Okay, stand by.
Okay.
All right.
Speed.
Stand by. I'm still sitting.
Stand by. Speed.
Okay, 1, 2.
Can't believe it's not butter. No, just kidding.
Okay. How many shots? Just one?
Yeah, just only have one for the.
I accidentally pressed it. I didn't know it was that
I
sensitive.
appreciate it, Dave.
Oh,
That's
no problem.
pretty rare you ever get an opportunity like this in your life. It's
Just gotta keep moving forward, man.
Well,
yeah,
that makes
it's
sense.
true.
One step at a time. Trying to- So did you have a chance to read on any of her papers or thoughts or anything last night, or?
Well, the thing I had was, I thought about, I like that LinkedIn a lot. Because I looked at some of them and they pointed out
You want me to take
who
another
they
one?
were and what they did.
No, it's good.
Yeah.
Okay.
And that was like you said, you know, I
Yeah.
thought about what you told me, how valuable that LinkedIn is. And it's a lot more valuable than a lot of people realize.
You just have to now, I mean, you have to write those posts out, so I mean, I don't know if we're gonna use like these posts that you know, and that's what, those are the posts or whatever, but that's the thing now, I mean, we gotta fill these,
No, I was trying to figure out how to, you know, well,
Okay,
Steve
you
got that on
You
film.
guys take out the mic?
Yeah, I got it right
'Cause some people walk away and they go,
No, how I find those groups to join.
yep.
You know, to have them join me. First I joined.